Consider the checkered plane. Let's introduce a new figure on it. It will beat 20 random cells depending on its location. These cells and the figure can be positioned as you like, and that's all you know. Now imagine that you have two such figures. They are also located somewhere on the plane, and you most likely want no piece to attack the other. Otherwise, it will fall apart. Is it possible to place them in the required way on the plane? Now imagine that you have a 100 by 100 board and 20 such pieces. Is it possible? It turns out that yes. And before we begin, subscribe to the channel. Consider a 100 in 100 square and arrange the pieces randomly. Let's consider the specific cases when the psi figure attacks the pi figure. Let's enter a random indicator value that characterizes this. We will put 1 if the figure beats its pair, otherwise 0. First, let's try to determine the probability of this event. To do this, note that the first piece can be located in all cells of the board, and the second in specific 20 cells, while the rest of the figures can be positioned as desired. In total, we get the number of unfavorable outcomes, and there are as many of them as in the denominator. So in the end, we get the following value. Let us now consider the following statement using the example of 2 dice. Let's prove that the value of the value in all outcomes cannot be greater than the expectation. Practice shows that there are values where the sum of the numbers on the dice is not more than 7. However, it is not difficult to prove this by describing the expectation through the definition. Now it remains to calculate that the expectation of the sum of all our values is less than 1. And this is true because there are only 20 times of 19 ways to choose a pair of different figures. Is it possible to arrange 21 or 22 figures? Write your opinion in the comments. You can watch my other videos where I solve IMO problems in a minute and explore regular polygons.